Hi everyone, today we will be talking about density. So density is the property of matter that describes the amount of mass in a given volume. So we can think of this as the ratio or the relationship between a substance's mass and its volume. So in practice, when we're talking about the density of a substance, and if you look at the image up here on the slide, this will make sense. Really, density is describing how much matter or how much stuff is packed into a given volume. So it talks about how compacted or how tightly packed the matter of a substance is in a given volume or a given space. So this means that if I have a substance that has a lot of mass in a given volume, we would say that this has a high density or that it is very dense. If we have another substance like this one on the left that has less or a small amount of mass in a given volume, we would say that this has low density or that it is not very dense. The units for density that we will use are for solids, the gram per cubic centimeter. So that is a mass gram unit divided by a volume unit, which is the cubic centimeter. For liquids, the unit that we use is grams per milliliter. That is because milliliters are the volume unit for liquids. The good thing here is that it is a direct one-to-one conversion between cubic centimeters and milliliters. So all you need to do is change the unit. So that means if I have 10 cubic centimeters, I also have 10 milliliters. They are a one-to-one conversion. So now let's talk about how we calculate density, which is something that you will be doing in this unit. So the formula for calculating density is rho, which is this small lowercase p looking letter, which represents density, is equal to m over v, or mass divided by volume. Now, as I mentioned at the beginning of the video, density is a property of matter. That means the density is something that can be used to identify and differentiate between substances. We know about properties of matter that every pure substance has their own unique set. Therefore, every pure substance, so every element and every compound, has its own unique density, meaning no other substance has the same density. For this reason, a substance's density can be used to identify it or differentiate it from other substances. That means that if I have an unknown substance and I'm able to measure its density or calculate its density, I can then compare that to the known values of substances and determine what the substance is. I also can use this to differentiate between substances. If I have two substances and I measure or calculate their densities and I find that they have the same density, that tells me that they are indeed the same substance. On the other hand, if I measure their densities and find out they are not the same, that tells me that they are not the same substance because they do not have the same density. Now let's look at how to measure density and a couple examples of how we would then use our measurements to calculate the density of a substance. So as we've just discussed, density is the ratio or the relationship between a substance's mass and its volume. So in order to measure the density of a substance, we of course would need to know its mass and its volume. So in order to do this, we of course will need to measure the mass, measure the volume, and then use our density formula to calculate the density. Now I'm going to show you a couple examples of how this is done in practice. So now let's look at an example of how to measure density in practice or in the lab. So here you can see I have 4 different cubes. Okay. Some of them look pretty similar. Some of them look a little bit different. One thing that you might right off the bat notice about the cubes as I have them sitting is that they all are exactly the same size. What you can't notice in the video, because you're not here to touch them, is that although they are exactly the same size, meaning they have exactly the same volume, they all have very different weights, or in science class, we would say masses. Now, after this video, hopefully you can tell that that is because all four of these cubes are made of different substances which have different densities. For that reason, although they are all exactly the same volume, they have very different masses. So now what we're going to actually do is take a couple of them and actually measure their mass and their volume and use it to calculate their density. So we're going to start with these two cubes here. As you can see, they look quite similar. They're both a gray color, okay? But again, if you were in class, you would be able to tell this one is very, very light, whereas this one is pretty heavy. So before we get started, I'll go ahead and remind you on the screen, we know that our density formula is density equals mass divided by volume. So in order to calculate the density of our cubes, we need to know their mass and we need to know their volume. Luckily, I have right here our digital scale, which can be used to calculate mass. I also have a ruler, which I can use since these are perfect cubes to measure the mass, the volume of the cubes. So I'll start here with this. My scale is zeroed. I'm going to go ahead and place the cube on the scale, and I can see that it gives me a mass of 21.7. So we will go ahead and call this cube 1. And for the video, just so we know, I'll say that's the gray cube. So we now know that this has a mass of 21.7 grams. Now, for the sake of time, I'm going to do this very quickly, but as you'll recall from our mass and volume lesson, in order to calculate the volume of this cube, I will simply need to measure the length of a side and then multiply length times width times height, which for a cube is all the same. In this case, my cube has a length of 2.5 centimeters. So in order to get its volume, I simply need to multiply 2.5 times 2.5 times 2.5, which gives me 15.63. So we're going to say that our volume is equal to 15.63 cubic centimeters. So now we're ready to measure the density of this cube. So we'll go ahead and plug in our values for cube 1. We know that the mass of this cube is equal to 21.7 grams, and we know that its volume is 15.63 cubic centimeters. Now all I need to do is plug that into my calculator, 21.7 divided by 15.63, which gives me 1.39. My units are grams per cubic centimeter. So we now know that the density of whatever this material is 1.39 grams per cubic centimeter. We'll then go ahead and repeat the exact same process for our second cube. Now, I'll go ahead and turn my scale on, make sure it's zeroed, and place it on the scale. You can see there that for cube 2, over here, cube 2, we'll just call this black, it's a darker gray. Okay, my mass is 128.4 grams. And as you can see here, it is indeed much more massive than the first. My volume, since we know they have exactly the same volume, I will just go ahead and use the volume that we measured for our first cube. Now we're ready to go ahead and calculate the density of this cube as well. So once again, we know that density is equal to mass over volume. My mass for cube 2, 128.4 grams over that volume of 15.63 cubic centimeters. I will plug that into my calculator. Come up with 8.2 1 grams per cubic centimeter. And this is the density. We'll say this is of cube 1, and this is the density of cube 2. Now, this gives us an excellent example of the conceptual understanding of density. So again, we can see here that although these two cubes had exactly the same volume, they have very different masses. As you remember from what I told you in the beginning of the video, this one is much more massive. Now we can tell from our density calculations that indeed the reason why this is so much heavier is because whatever this material is has a much greater density than the density of the lighter cube, meaning that in this material, the matter is not as tightly compacted as it is here. Now, to pull this together conceptually, I'm going to tell you the identity of the two materials that make up cube 1 and cube 2. Cube 1, which was our light gray cube, which had less mass, is made of PVC, which is just a type of plastic. And if you were to go on Google or in a book or anywhere and look up the known density of PVC plastic, you would find a value of 1.38 grams per cubic centimeter, which is the known value of the density of PVC plastic. You can see that our calculated density, even with human error and just using the simple materials that we have, is very, very close. That means that if we did not know what this was made of, we would have been able to use our calculated density to identify this cube as being made of PVC. Our second cube, cube 2, which was our darker, heavier cube, is actually made of iron, which is an element you may have seen as we studied the periodic table, has the symbol of Fe. Now, if you were to look up the density of iron, you would get a value somewhere in the range of 7.8 grams per cubic centimeter. Now you can see that our value is a little bit further off for this. Now, that is simply because we are using very rudimentary materials, and perhaps my volume calculation for this cube was not entirely perfect. It does have some beveled edges, which may have slightly thrown off our number. But you can see that just with a small amount of error, 7.83 is quite close to the value that we got of 8.21. So again, if we were to conceptualize what we calculated and what we measured experimentally, we could confirm that these two cubes are not made of the same material. And with some error, we could identify this is made of iron, and very, very accurately that this is made of PVC plastic. So we used the density of these two materials to differentiate them from each other and to identify the substances that they were made of.